In this video, we will describe demand function. So, demand function is a relationship between price and quantity. Quantity is the dependent variable and price is the independent variable. And we can describe the demand function in three distinct forms, and we will see how all of them, each one of them are equivalent to the remaining two. So first I will start with a mathematical formula for a demand function. So I have Q, which is the dependent variable, as a function of price. So I write it as Q equal to 10 minus P. I have already introduced the notation, Q for the quantity and P for the price. So I should write here again, P is price, Q is quantity. So that's a relationship. It tells us that if we know what is the price, we can find out the quantity of the commodity which will be bought, by which all the buyers in the market are willing and able to buy. For example, if P is, let's say, $1 per unit, we can find out Q is 10 minus 1, 9 units. I can give another example. Let's take P to be $7 per unit. Again, Q would be 10 minus 7, 3 units. We already know price and quantity have a negative relationship. So as price goes up, quantity goes down. This formula also reveals one more information, and that is if price goes above $10, then there is no buyer willing and able to buy the product. So in a sense, the maximum willingness to pay for the product by any buyer in this market is less than $10. So that's an important observation we could see from this mathematical formula. We could also have the second way of describing demand, which is the data containing price and quantity pairs. So for example, let's have price on the column on the left, quantity column on the right. So suppose we know that when price is $9, quantity bought is 1 units, price is $7, quantity bought is 3 units, 5 and 5, 3, 7, 1 and 9. Suppose we are given this data. So obviously price is in dollars per unit, that's the unit, and then quantity is in units. This is perfectly fine description of the demand function. We know if we are given the price, we can find out what is the quantity which all the buyers in the market are willing and able to purchase. Obviously, you could see we can have only finitely many data points. These are actual observations which has been noted from any given particular market. So the number of data points would be finite, would be limited, and then we will make some assumptions about how to how to interpolate. So if suppose we want to find out what will be the quantity bought when price is neither $9 nor $7 but a number in between, for example $8. So we will say we can assume that we will assume a linear relationship between price and quantity for the price values which are in between any of the points observed here, any pair of points observed and noted in this table. So this is the second method. The third one, we can draw a graph of price and quantity for any product. And here I want to introduce the convention that even though we have noted in the beginning, price is the independent variable, quantity is the dependent variable. So typical graph in math class would be having quantity on the vertical axis being dependent variable and price to be on the horizontal axis as it is independent variable. But the convention in economics is slightly somewhat different. Here we will always have the price on the vertical axis and quantity on the horizontal axis. So Q here, P here, and that's the convention. So let's write down the unit for price, dollar per unit, and then quantity is units. And we can draw the relationship between price and quantity in this graph. So for example, let me draw a graph which looks something like a straight line with vertical intercept $10 per unit and horizontal intercept again 10 units. So now we can see all these three formulations of the demand function could be related, could be interrelated to each other in the sense that suppose I am given a demand function, I can describe the information about price quantity pairs as given in the table based on the formula, as well as I can draw a graph. I can go in the other direction. Suppose we are given a graph of the price quantity relationship. We can make a table, we can prepare a table of price quantity pairs, as well as if the graph relationship is well behaved, maybe we can write down a mathematical formula. The same thing could be said about the table, the data available in the table, based on which we'll assume the relationship between the price and quantity. Suppose we assume it to be linear, then we can draw a graph based on the data points, as well as we can write down a formula of the price quantity relationship if the relationship is well behaved. So we can see that the formula I wrote here, quantity equal to 10 minus P, is actually, if we draw the graph, it is exactly what we have seen here in this graph. And then we can also verify that the data we have listed there actually pertains to the same mathematical formula. Now I want to spend some more time looking at what we started with. We said we will write down a mathematical formula for the demand function. So at this time I want to take somewhat different numbers. Let's say 30 minus 5p. So this is the mathematical formula for the demand function, but as we noted, when we draw the graph, we draw the graph with price on the vertical axis and quantity on the horizontal axis. So we will call the function drawn in the graph as the inverse demand function. And it is possible, given the demand function, it is possible to convert it into the inverse demand function, in the sense of I need price on the left hand side and quantity should be on the right hand side. So let's use this formula and see how we can compute, how we can determine the inverse demand function for the demand function given here. So I have Q equal to 30 minus 5P. I would like to move P from the right hand side to the left hand side, and to do that I want to add 5P to both sides. So this gives me Q plus 5P. On the right hand side, negative 5P and positive 5P cancel each other out. So what remains is 30. Now I don't want Q to be on the left hand side, so I will subtract. And what remains is, now we have 5P on the left, 30 minus Q on the right. And then lastly, we want P by itself, so coefficient 5 needs to be removed. So I will divide both sides by 5. Remember, when I am dividing the right hand side, 30 minus Q over 5, this is same as writing down, simplifying it as 30 over 5 minus Q over 5. So now I have P on the left hand side, 30 over 5 is 6 minus Q over 5. Some of you may even like to write it as 1 over 5 is equal to 0.2, so 6 minus 0.2 Q. So if I am given the demand function Q equal to 30 minus 5P, it is possible to convert it into the inverse demand function. And now you can see the graph for the demand would be a graph for this inverse demand function. So let's draw it. So first I have to have Q on the horizontal, P on the vertical. Unit is P in dollar per unit, Q is in units. We can specify any unit which is applicable in this case. And you could see if quantity is 0, price is 6 minus 0.2 times 0, so that is $6. So the vertical intercept would be 6, and the horizontal intercept, if P is 0, we could go back to the demand function to see that the quantity was 30. So I have 30 here, 6 there, and I want to connect it with a straight line. This will be the graph for the inverse demand function. So let's write down the steps. Given demand function, we need to change it, convert it to inverse demand function, and then draw the graph. Then graph the inverse demand function. It is also possible, in case we are given the inverse demand function, then drawing the graph is straightforward, but we could compute the demand function based on the inverse demand given to us. So let's take an example of inverse demand function. Price equal to 60 minus 5Q. Now I want to change this inverse demand function to find out the related demand function. So let's start. First we will write down the inverse demand. Now I want Q to be on the left hand side and P to be on the right hand side. So I have 5Q here, 5Q there. So what I obtain is P plus 5Q. These two cancel out, 60 on the right hand side. I want P to move to the right, so I will divide. What remains is 5Q equal to 60 minus P, and now I need to divide by 5 to obtain Q by itself on the left hand side. So the right hand side could be rewritten as 60 over 5 minus P over 5, or Q equal to 12 minus 0.2 P. So if we are given the inverse demand function, we can find out the demand function as well. Lastly, suppose we are given a table, data points, and then we are also given that the relationship between the price and quantity is linear. Then we can find out the demand function based on the data point. So let's take an example. I have P and Q here. So let's say when P is 20, quantity is 0, P is 18, quantity is 4, P is 16, 8, on and on. For some more points, I will write at least one more. P is 14, this becomes 12. You can see when P is $2, quantity is 36 units. And given this, we are given this data points, and we are also given that the relationship between price and quantity is linear. Then we could write down the formula for the price quantity relationship. You could notice as price goes down by $2 per unit, quantity goes up by 4 units. This is happening every time. From 20 to 18, decline in price is $2, quantity goes up from 0 to 4, then 4 to 8, on and on. Which means now we should be able to write down quantity equal to, so price is going down. No, I should write down the slope first. Slope of the demand function price is going down by 2 units, quantity is going up by 4 units, so the relationship is negative. I will write it as 4, so 0 minus 4, that's the change in quantity as price goes down from 20 to 18. So 20 minus 18, I have negative 4 over 2, negative 2. So the slope for the demand function is negative 2, and then we could see that the quantity would be close to 40 units when price is close to 0, So I have the horizontal intercept to be 40. So 40 minus slope 2 times P. And we could say this formula describes the information given in this table, based on which I could also draw the inverse demand function. I have Q on the horizontal, P on the vertical. The horizontal intercept is 40, and we also see from the table the vertical intercept is 20. So the relationship between price and quantity, which is the inverse demand function, is 20 minus Q equal to 40 minus 2P. So this is the demand. Now I can also find out the inverse demand, which is what has been drawn in this graph. So inverse demand, I have Q equal to 40 minus 2P. I want to leave it as an exercise for you to see that from this demand function the inverse demand would be given as P equal to 20 minus 0.5 Q. So this is the demand and this is the inverse demand. I will stop here now.